Assalamualaikum and hello to everyone. Let me introduce myself. My name is MOHD bin DANURI. I'm from Center of Technology in Marine Engineering, Department of Marine Engineering, Politeknik Ungku Omar, Ipoh. So my study is the thermal comfort analysis in full-stroke marine workshop in Politeknik Ungku Omar using finite element method. In this slide, I'm going to talk about research overview, problem statement, the objective of the studies, the scope of the research, the methodology, and then result and discussion, lastly the conclusions. Indoor air quality describe how indoor air can affect health, comfort, and the ability to work. Among the aspects that affect the quality of indoor air are the temperature, the relative humidity, the fungi, the bacteria, the poor ventilation system, and the exposure to chemical. By referring to the American Society of Heating, Refrigerating and Air Conditioning Engineering, or ASHRAE 1999, defined that the indoor air quality as air is allowed where there is no concentration of pollutants as dangerous as defined by the authorities or by a large majority of people exposed do not express the dissatisfaction. By referring to the Industry Codes of Practice on Indoor Air Quality 2010, published by the Department of Occupation, Safety and Health, Ministry of Human Resources, Malaysia, or JBPKK, there are many resources of indoor air pollutants, and among the common are environmental tobacco smoke, or ETS, emitted due to the burning of tobacco product, for example, cigarette. Various chemical substances, such as formaldehyde, emitted from furniture. Volatile organic compound emitted from the use and applications of solvents. Ozone emitted from photocopiers and laser printer. In my case, the diesel engine. Among the health effects caused by poor indoor air quality are allergies and asthma due to exposure to the pollutants such as dust and fungi. Discomfort due to extreme cold. Infectious diseases through the air and symptoms of breathing syndrome pain such as dizziness and headache, extreme fatigue, and skin problems. By referring to the of practice on energy efficiency and use of renewable energy for non-residential building, or MS 1525/2007, published by the CIRIM, or Department of Studies Malaysia, room comfort conditions should consider the following three main factors: the value of the dry bulb temperature, the value of the relative humidity, and the condition of air movement or air velocity. By referring to the Industry Code of Practice on Indoor Air Quality 2010, the parameter for air temperature, the acceptable range are 2007-23 until 26 degrees Celsius. The parameter for relative humidity, the acceptable range are 40 to 70%. The air movement, the acceptable range for air movement is 0.15 until 0.5 meter per second. However, for referring to the ASHRAE standards, the temperature range should be between 20 degrees Celsius to 37 degrees Celsius. For the wind velocity, must not less than 0.2 meter per second. By referring to the Department of Studies Malaysia, or CIRIM, the human body temperature need to be maintained at a constant temperature at 37 with a plus minus of 0.5 degrees Celsius, regardless of the prevailing ambient condition. The problem statements. From the research review, we can summarize that the problem statements for these studies are: poor ventilation can create a discomfort and low air quality. It also can create a serious health problem issues. And uncontrolled working condition can escalate fatal accidents in the workplace. The objective for this research are to investigate the level of thermal comforts and distribution of heat and air movement, and then to improve the thermal comfort level by optimize the distribution of heat and air movement. So this is the research scope. So in this research, the elevation's height is 1.6 meter in y-axis. This represents the breathing height for normal person in Malaysia, and 7 meter in y-axis, it represents the conditions or the height for the air movement and air distributions near to the ceilings of the workshop. The location is 4-stroke military engine workshop. The ventilation system is the natural ventilation system with a cross type of ventilations. And then the measuring data is distribution of heat from the heat source and the air movement inside the workshops. So this is the cross ventilation system that apply in my workshops by referring to the picture below. The methodology for this research. So this is the flow chart study, information collections, and then adjustment of the measuring equipment, the capture and recording of data, data verification if yes, conclusion and recommendation if no, it return back to the capture and recording of data. So this is the program structure for the simulation software. Start with the computer assisted design software, and then go through the machine process, and then the solutions, and then if it's not so, go through back to the data assessment processing, and then you go back to the solutions. So this is the 3D model for the workshops. The red line is, represents the heat source or the diesel engines. There is 2 window, exit window inside this workshop, and there is 2 ventilation window. Sorry, there is 2 door, exit door in this workshop, and there is 2 ventilation window in these workshops. Which the level is 7 meter from the floor. So this is the actual picture for the workshops. The left side is the right side. The left side is the front of the workshops. The left side is the back of the workshops. Result and discussions. So this is the result from the simulation software showing the velocity contour 1.6 meter from the floor, or the breathing level for normal person in Malaysia. So this is the velocity contour for air movement 7 meter from the floor, showing the condition of the air movement near to the ceiling. So the value for breathing level or 1.6 meter from the floor, the maximum value for the airflow is 0.48 meter per second. The average value is 0.192 meter per second. When compared to the standard assured standards is 0.065 meter per second more than it should be. In the lattice window or the ventilation window, which is 7 meter from the floor, the maximum value is 0.768 meter per second. The average value is 0.195 meter per second, or 0.255 difference or more than the standard value. So this is the picture or the output for the contour distribution of temperature 1.6 meter from the floor. So this the total or the temperature contour or the heat distributions 7 meter from the floor. So the breathing level for the temperature distributions or 1.6 meter from the floor, the maximum value is 333 Kelvin or 59.95 degrees Celsius. The average value is 312 Kelvin or 38.85 degrees Celsius. We 11.85 degrees Celsius more from the standards. The lattice window level or 7 meter from the floor, the maximum value is 307 Kelvin or 33.95 degrees C, the average value is 309 Kelvin or 32.85 degrees Celsius or 5.85 degrees Celsius more from the standards. The conclusions show that the temperature distribution for the workshop is still beyond the range of the level of thermal comfort guidelines specified by the ASHRAE, by the CRIMS, and by the JBPKK. The natural ventilation system has less impact on the circulation of heat flow and distributions for the heat distributions in the workshop. So it not recommend in the confined space or in the space where the machinery produce harmful gases. So I propose that a new ventilation system need to be proposed in the future to help the better air circulation and heat displacement in the workshop. I hope my explanation is clear. So if you have any questions, you may ask in the Q&A session. Thank you very much.